follow me at Jason Bach. Again, I work for Magenic. That's their website. If you want to get a hold of me after the talk, have any questions about both the stuff I'm going to present, it's jasonb@magenic.com. I'm also a Microsoft MVP in C#, and I'm a speaker, and I run a couple events in the Twin Cities. I'm part of the leadership team at the Code Camp up there, and I run the Twin Cities Language Institute. So if you're in the area when those events are going on, you're more than welcome to attend. All right, so what is PEX? This is a tool that came out of Microsoft's research area. They have a really large research group within Microsoft, and they produce all sorts of interesting tools that have some advanced capabilities, but sometimes that's the space they stay in, and sometimes they actually start weaving their way into tools that you use on a day-to-day basis. There's one site that they've set up called the DevLab site, where they have some tools, one of which is PEX, there now. And the DevLab site is going to be stuff that's come from the research area that actually seems to have a fairly potentially interesting use among widespread amongst most developers. So that's where you can find out and get PEX if you want to use it. So what is it? The first three bullet points I pulled from various different sections of their websites. It says that it finds interesting input-output values. Okay, so you have a method, and you say, I want to have PEX run on it. PEX basically looks at what's going on underneath the scenes to figure out what can or can't this method do. And it does this using the second bullet point, which is it does all this static analysis. Actually, it's static and dynamic analysis. I'll explain that later in the talk. To find all these exceptional boundary conditions in your methods. It also sets up and enables parameterized unit tests. When it actually does this analysis on your code and looks at what your method could do, it actually creates tests for you. And when I did this talk at the Twin Cities Code Camp, when I did the talk, I actually came up with the acronym TDD, text-driven development. You have like test-driven development, behavior-driven development, and now I'm throwing out this other term called text-driven development. Because PEX actually creates unit tests for you, but it's all driven from PEX. So I've got this question a couple times when I've done this talk, which is, does PEX eliminate unit testing? And my opinion is it doesn't. You still need to do unit testing, you still need to have integration testing, you still need to do that testing on your own to handle kind of those conditions. And I think the code does this, so I'm going to write a test to make sure it does or doesn't do the things I want it to do. What PEX does is it can do that, but it also can drive into some very weird boundary conditions that you may never have thought of before. They've actually used PEX on a lot of Microsoft core assemblies like MS Core Lib and Friends to find out what are some things that it has as bugs. And I think PEX has actually found like 10 or 20 really odd, obscure bugs within the .NET framework that they've never found within their exhaustive suite of tests. So it's really interesting to see what PEX does, but you almost have to just dive into it and give it a whirl to see just what it really is capable of. I'm not real thrilled about using movie quotes when I do presentations, but I really feel that with PEX, it's almost like the movie Matrix when Neo is like trying to figure out what is the Matrix, and Morpheus says to him, no one can be told what the Matrix is, you have to see it for yourself. And I know it's a little corny, but I do think it's actually very applicable to PEX. To really appreciate how powerful it is, you have to see it in action. So this talk is actually extremely demo-driven, so you can see just how it works. And the more I play with PEX, the phrase that actually comes from a fairly well-known modern phrase, the what will Jesus do? I actually feel like it's very applicable in this case. It's not what would, but what will PEX do? And it's also kind of funny because the PEX mascot symbol is a shark. So it's also kind of analogous to the what would Jesus do? But actually, we get a shirt that looks like this. I'm working on that. But again, it's not would, it's what will it do? And it's not that PEX is doing anything, well, it's doing some obscure things, but it's not doing anything quote unquote magical. It's following, pretty much standard comp sci stuff that you would do to analyze your code. But I'm always amazed when I've had to analyze my code or other pieces of code that I've found to see just what it comes up with. Okay. So every time I do it, I'm always sitting there going, well, what will it do this time? So I'm going to spend a fair amount of time going through some demos and show you how PEX works. The first one is a string parsing example that I found online. I'll explain what I mean by that in a moment. The next one is a datetime formatting piece of code that somebody at Magenic actually found at a site that he's working on. It's quite interesting. And then the last one is the Zune bug. So if you have or know people or heard about the whole thing last year with the Zune, basically locking out, we're going to go through that piece of code as well. Okay? All right, so I'm going to dive into my VPC here. Okay, so let me get into the first one, the string parsing. All right, now what I'm actually running here in my VPC for Visual Studio is 2008 Team Edition for developers. PEX, when you install it, you go to their site and install it, it only works for 2008 and 2008 Team Edition and above, or 2010, whatever new term they've come up with, because they have slightly different naming now for the 2010 product families. There's like Ultimate and Premium and stuff like that, I think. So I'm not sure exactly which one with Beta 2 now and with the actual eventual product for 2010, what that maps to here. But I know people that have tried to use PEX after I do the talk, and they told me that they try to do it in professional and it doesn't work. Okay, so that is a potential showstopper if you want to play with it. It does install when you install it. It will put some command line tools that you can actually use as well that basically the IDE integration is using. So you can still play with it a little bit to see what happens, but in all honesty, having this actually in the IDE is a much nicer experience. Okay? And the version that I'm using here is 0.18. They've actually done a couple of they've done a couple of revisions in recent history, which have actually made a couple of things I'm going to talk about later with stubbing and mocking much nicer. Okay. So that's the version that I have here. And this first piece of code is some code that I found on a website that I was looking up stuff on inversion control dependency injection because we're using that on a project that I'm on right now. And I wanted to get a little bit more familiar with the terminology. It's something that I understood, but I wanted to actually find something that kind of walked it through a little bit deeper. And I found this 4-part series of articles that go through DI and IOC. It's a decent set, I liked it. And what the guy does in his examples, he goes through and says, think about the classic example where you're trying to bring content down from a website. So you use web request and web response, write your code, pull that down, and you start parsing the HTML right from that. And his example is pull that web stuff out into another class, use an interface that's injected into your code, and then parse that stuff rather than having a dependency on web request and web response. Okay. And so then he gets to this one method where instead of having that do the web stuff, it's just now looking at the contents of what came down from the web result. And what this piece of code is trying to do is find the contents within the title tag. Okay? And for some reason, when I was just reading this code, it triggered in my head as I'm reading this going, I think there's a bug in here. What is it? That's one. If the contents are null, you're automatically assuming that it's going to work. Okay? So that's
culture of the thread running is an issue too.
With the string comparison current culture. Yeah, I actually like that they actually explicitly say it's the current culture which is running in rather than.
You do it variant or something. Just
yeah. Yeah, there's a couple.
Assuming they're in the right order, I mean, you're going to call up your substrate probably.
That's the one that I saw. There's other ones like you've seen that also kind of struck me, but that's the one that I saw, which is if for some reason the contents has the title tag, the closing one, before the opening one, the substring is going to blow up. Which seemed a little odd to me because they're actually doing a check to say, well, did you even have an opening tag and a closing tag? Okay, so if they're going to do that check, then the code, in my mind, should have also said the opening tag index should have been before the closing tag index. Otherwise, when you look down at the bottom here, you'll see that it actually sets the return value to string empty. So in my mind, what it should do is if you have that reversed scenario, don't try to do the substring, just return a string empty. Yeah.
So this kind of borders on the whole, you can program defensively and think of all the different things that can happen, or you say, well, if we're actually in the parsing HTML document, we're going to assume that it's well-formed.
Yeah, because nobody ever does ill-formed HTML.
No, I know, but I'm just saying, no, I agree. But it's like, so where do you fall back? Because again, there is a bug there.
Right.
But it's like, most people are, they could get the title thing wrong. It's one tag. I could see now, a lot of people don't close TD tags and TRs and that sort of thing. The title tag's kind of an obvious one that most people don't mess up. I've never come across it wrong.
Yeah.
But I have come across a lot of other HTML that's wrong. So, I don't know, again, don't want to get down the weeds, but is this sort of thing where you wanted to use PEX to program defensively and check, or is it just going to tell you where a potential problem could exist?
Well, you'll see when I run it, what it gives.
Okay.
And I'll explain kind of what you have to do with the interpretation of the results. It does get to a general argument of how defensive or how not defensive do I get in my code. One person has mentioned that I'm just blindly using the argument here without checking for it to be null. And there's a book that I highly recommend if you're doing .NET development, or really any development. It's called Framework Design Guidelines. And it's a wonderful book. I highly recommend it. Framework Design Guidelines. And get the second edition. The first one's great, but there is now a more recent edition that came out. One of the things, among many things that they recommend, because it's a book kind of like rules of thumb, best practices, things you should or should not do. And they say that if you're going to use an argument that's reference-based, the first thing you should do is actually check to see if it's null, and if it is null, throw an argument null exception. Because that will give the person that actually coded it wrong more information that it's actually the argument that failed, and you can also then put in the name of the argument and say that's the one that I missed. Okay. So you're going to see that PEX actually recommends that code in a moment. But that's one thing that you could put in there. You do something like, well, most people should have, according to HTML guidelines and rules, yes, the opening should be before the closing. Okay. So I don't want to, in this piece of code, it is a demo piece of code, so I'm on the website. So I don't expect it to be extremely hard per se. It's just something that I noticed when I was reading it going, hey, wait a minute, this doesn't make a lot of sense. And so then in my mind I said, well, what would PEX do with this? So that's why I included the example. Okay? So what would PEX do with this? When you get PEX installed, all you have to do is right-click in whatever method you want to PEX and say run PEX. That's it. Now I'm going to start it up because PEX is extremely computationally expensive. It does take a fair amount of time for it to figure out what it needs to do, depending on what the code does. Even a simple code snippet like this, it takes a little while for it to figure everything out. So I'm going to fire it up. And then while it's doing the stuff that it needs to do, I'll mention that if you have a non-public member, PEX can't hit it. Because again, PEX is about testing, and it does it from the perspective of I can't get into the private internals directly. Now, it's instrumenting your code to figure out what it can hit and can't hit. But it's not going to try to hit code that a normal person couldn't hit if I was using this class. Okay, so if this method was protected or private, and I tried to right-click and say run PEX, it wouldn't let me do it. Okay, so it's only public members. All right, so looks like it got done. And one thing I've noticed about PEX is that it doesn't seem to honor the huge view that I use for Visual Studio, which is not just the fonts, but also the menu options and everything. I have the font size much bigger, and it doesn't. So thank God for Zoom It, because I'll actually dive in so you can see what's going on down below. A couple things I want to get into before I show you the results of what it found. One thing that it has up here is it has this thumbs up or thumbs down. PEX is really, really good about listening to your feedback. There's two people that really are the core members of the PEX team at Microsoft. One of them goes by Haley. If you ever use this and have questions and something doesn't make sense or you don't understand anything, you can contact them, and they turn stuff around really, really quick. So for one thing, you can actually say, if there's something that really impressed you about PEX, you can just say thumbs up. And what this will do is, because this is a VPC, I don't have anything set up like Outlook or anything like that. It just uses Outlook Express. But it just generates an email message for you with everything set, and then you can just type whatever you want in there. It just sends it off to the team. There's just a little nice integration thing that I like that they did. You can also do the thumbs down if you want as well. So
That just was the VPC.
yeah. No, they're honest. They'll say thumbs down. I mean, it just changes it from thumbs up to thumbs down. Actually, in 018, they had the to email had like all the content for the subject, and they've changed that now, so it's a little cleaner. They also have, if I can find it here, see if I can pull it over. Yeah, ask a question. Okay. So you can also go right from here, if there's something that doesn't make sense, fire right into the social online site for PEX, and they'll turn your answers around really quick. Okay. So use that to your advantage if you're diving into PEX.
Do you know what the long-term plan for PEX is? Is it to like roll it into the framework at some, or into this tool at some point, like PS 2012, or do you know the roadmap?
Do I know the roadmap? No, I don't. I actually haven't loaded Beta 2 for Visual Studio 2010 just yet. I haven't had the time. From what I understand, PEX is not in there, even like in the Ultimate suite. So if they're not in there by Beta 2, they're not going to be in there. It's too late in the cycle. I really honestly don't know what they're ever going to do with PEX. Is it ever going to be productized? Is it ever actually going to get into the VS suite? Don't know. Okay. So right now, with PEX, the licensing did change. It used to be an academic license. That's now changed, so it's more of a license that's friendly for people who are actually doing commercial development. But no, I don't know what, if they're going to eventually do like 2012 or 13 or whatever the next one will be after 2010. All right, so we got some of the stuff up here. I'm going to go to some of these tool items in a moment. I'm going to go down and look at the results of the test right now. So what it does is it says, first of all, it says, what's my target? And it realized that it needed to actually create an instance of that class. Because again, it's all parameterized, so it's going to look at everything it needs to pass in to parameterize a test. And you'll see the test that it actually wrote in a moment. It also realized it needed to do something with contents that is, that's the argument, that's the string argument. So that's where it's putting all this junk in. Because when it's analyzing the code, it's figuring out, if I do this, then what will be the result? And PEX is extremely analysis agnostic. It doesn't try to tell you this is what you should do or this is what you shouldn't do, more or less. It only cares about, this is my object, this is the method, it takes these arguments, so if I can change these arguments to do this, what do I get out as a result? And you have to interpret the results. So in the case where I'm actually, if I go to the results over here, you'll notice that with the null, that you see a null reference exception. Okay? And when you click on these, it gives you some information about what it actually found. Okay, so in this case, it's saying here, for that one where it's passing in a null, that tells you, yes, I found a null reference exception, that's the result. It also will start to give you some information about how you can change some things, how you can fix things. There's a save test button, an add precondition button, and an allow exception. Okay, I'm going to zoom back out. I just want you to see the buttons that it's giving here. And then I'm going to click on them so you can see what they're actually going to do. The save test, what that's basically saying is, this is the test code here. That's the test code it generated to actually get the result. So you see it's got a string S. It creates the parsing title scraper, and then it passes in, actually null, it's trying to get the result back from scrape, that's what S is. But it's going to pass in a null to that method. So that's actually the code it generated. You can save that code if you want. Okay. So you can go through all the work to do it if you follow all these steps, or you can have PEX just do this and say apply. I'm going to do that in a moment with with another one down here below. So I'll show you that it just generates all this code for you in a moment. In this case, it determined that, well, wait a minute, you're using an argument, it's reference, you should actually check it for argument null. So do you want me to generate that code for you? Sure. Boom. So it is giving you, in this case, a little bit of guidance. So in some scenarios, its analysis is agnostic, but it will take the results from the analysis in Visual Studio and tell you, you might want to actually check to see that that argument is null. I don't have code contracts installed on this, so I don't know if it would be smart enough to say you do have code contracts, so it would put the contract requires in here. But I do know that PEX and code contracts are actually very tied to the hip in a lot of ways. So it wouldn't surprise me if they did that. But either way, it's putting that code in for you. Okay. Let's back that up. All right. Let's take a look at some of these other results over here. You notice that it looks for a string empty to see what the results are. It gives me a string of, what, 6 or 7 null characters in there. I don't know why I thought that was important, but that's what it picks. Okay? Gives you a string of 13 null characters. And now it starts getting interesting. You notice that it's generating a string as the input that's putting the opening title tag in there. So it's able to analyze my code and saying, well, you did something with a title tag, and you're going to do something with it in the substring, so that seems important. So I'm going to start adding that I'm going to add that in as input. That's kind of cool. All right, now, one thing you're going to see a lot of when you do PEX is you'll come up with these boundary conditions. Because PEX is so computationally expensive, it's not going to automatically try to follow all your code paths. Because if it does, it would take out of the gate sometimes minutes, if not hours, to actually finish the analysis. So it limits itself pretty hard and says, if I can't get my analysis complete after like a second, I'm going to stop. But what I'm going to do is I'm going to tell you that I hit some boundary conditions. So if I click on that, it's going to give me some max constraint solver time exceeded. It basically said I couldn't finish my analysis, so I want more time. So if you want to give it more time, in the details pane over here, you can say set that solver time up. So that it will try then to double it. Instead of being 1 second, it's now going to be 2 seconds. And this is also where the generation of the code comes into play. So you can follow all these 13 steps, or you can just say apply and do this all for me. Now, one nice thing about PEX version 0.17 and beyond is they now allow this to be editable. They didn't let you change the name of the assembly when it generated it, and I already have a test assembly named stringparsing.test. So what it would do is it would do the 1, but then it wouldn't let me change that. Well, I thought that was kind of ugly, but they now have that there, so it's a nice little addition. So I'm going to call my name of my assembly PEX, say OK, let it do all the 13 steps that it needs to do, and once it's done,
So just to change it to 1 second to 2 seconds, it's going to create an assembly. And
what it really needs to do if you follow the steps is it just needs to put in one attribute to say, take 2 seconds rather than 1. In this case, I just wanted to generate the assembly so you can see this is the assembly it makes, this is where it would put generated tests and so on. You don't have to follow the steps. You can look through the steps and go, oh, this is all I need to do, I'll do it manually. Okay. It's up to you. It's just giving you, if I just want you to do this, just generate this and off you go.
If I'm jumping ahead, correct me, but so the idea that if you had some code, you run PEX against it, take all of the output tests, put it in your own assembly, and then just add those as part of your test suite, or you're running PEX proactively every build or every time. You just run PEX occasionally to find the missing stuff.
Yeah, I'm going to talk about a tool that I'm writing to do some analysis off hours, so to speak, because this is something that I don't think you do on a day-to-day basis per se. So yeah, you're jumping ahead a little bit, but
Sure.
I'll address it later. But yeah, you can, when you initially do it, if I wanted to save all those tests, I could just say save them all, put it in an assembly, and then I could actually have that as part of my build process, and then have those tests just automatically run all the time, because they end up being part of your test suite. And it's now honoring other test frameworks than just MS Test, which which is what I'm using here. So you didn't see it here, but when you first install PEX, and you run it against some code, it will ask you which target framework do you want to use, and I think it supports now XUnit, NBUnit, NUnit, and MS Test. So it will generate code relative to those frameworks for you.
Oh, cool.
Yeah. All right, so now I got that in there, and this is where it gets to the point of sometimes this works and sometimes this doesn't. Part of it's just because of how quick it actually executes. Sometimes just because it's a 0.1, it doesn't do everything the way I want it to work. But we're going to see if it actually gives me the result now because I've given it more time. I want to see if it actually ends up generating the result that I think is actually really cool. So we're going to let it do all of its testing again. And after it does all of its analysis, it starts doing more tests. Does it actually get the one that I wanted? Yes, it does. Cool. All right. So check this out. It's actually smart enough to realize if I do that condition that I saw in my head when I saw the code online, it actually generates a test for it. Get the title and title tag before the opening test tag. That's cool to me. I really thought that was amazing that I can do that. So now I found some value that I pass in that actually will cause, if you go out of here, an argument out of range exception. So that's the first example. Let me dive into another one.
Can you dive in there and then it will tell you where the problem is was? I mean, you did that last time with
Okay, right there. So double click on it, goes right where it's going to happen.
Okay.
It's saying that's where the exception occurred.
So then you can handle it there.
Yes, and I can look at it and go, oh yeah, I don't have, and do the if check and add another and condition on it.
Okay, cool.
All right, so the second example that I want to do is called datetime formatting. So, you notice that I have actually a lot of space here is because I don't want you to actually see the implementation that we found. So here's a scenario. There's a guy from Magenic, he's out at a client, and of course I can't tell you the name of the client that we work with for legal reasons. But we'll tell you this, if I did tell you the name, everybody in this room would know who this client is. It's not like a small shop, it's a big client. And he's part of this project that's a really, really huge project. And he has, I think almost literally hundreds of developers on it. The thing that he gets into is one part of it, and he's not starting a greenfield. This has already been in development. So he starts getting in the code, and he's finding all sorts of what I'll call gems. Pieces of code that just made his head spin. Like, why in the world would you ever write code like this? And while you're going to see the real implementation of what this person did, not our consultant, what the other person did, it is a little scary that code like this actually gets written at sites that are going to be put into production to do things that if you knew where this was actually going to be happening, you'd really be scared. I mean, it's funny, but it's also scary. I'm not kidding as to why. So in this specific piece of code that they found, the scenario is, here's a datetime, and what I need you to do is format that datetime as month, day, year, because that datetime is going to actually be printed onto a label. Okay? So, if I'd ask you how would you do it, you'd probably do it something like this. Okay? Maybe not making it an extension method, so on and so forth. But the point is that you're just going to use the datetimes, like a custom datetime format string, and say just print it out like that. Okay? Probably, right? Well, you'd be wrong. That's not how you do it. This is how this guy did it. So he creates a string array of 13 values from 0, 0 to 12. Then using that string array, he indexes into it. To get the month value, concatenates that with the day value, and then he just looks at year and says, give me that value as a toString. Puts that all together and returns it. That's impressive. There's other words I had come to mind when I first saw this. Because there's so much wrong with this, I can't even tell you. I mean, this is just amazingly bad. Now here's the kicker. When our consultant is doing a code review and they look at this piece of code, because there's an obvious bug here, they asked him, did you actually test this code out? He's like, oh yeah, I ran it, it works. And I will give him this. It will work under a certain condition. Now, why would this actually fail?
13th day.
13th day. 14th day. Because you're going to start going out of the array depending on your day. The month is fine. This will actually work. Again, not the way I do it, but that will work. What's that? Well, yeah. Well, the month, if it's January, it will be 1. So it's going to index 0, 1.
Okay.
So that does work.
Okay.
Yeah, I know it's a little confusing.
So then get the offsets with the
Yeah, again, there's just so much wrong
I
with
just
this.
didn't know about the framework.
Yeah. So the month is the day is going to cause the problem. But if he ran it at the beginning of the month, then yeah, it would work. So he's going to be right about what, 40% of the time, whatever the actual ending, 12, 13 days or whatever that is before at the beginning of the month.
Probably good enough.
What's that?
Probably good enough for that kind of level.
Yeah, good enough. He sent me this and I went, oh wow, this is just awful. And then I went, what would PEX actually do with this? What would it find? Would it actually find the bug? It does, but it also finds an interesting addition that I didn't expect it to do. So I'll do run PEX.
Now, to back up what you previously showed, is it running with a 1 second time frame?
Yes.
Okay, so that, gotcha.
Yes,
You
because
didn't change some global setting for
no,
PEX?
that was for that specific string parsing concept.
Good.
So it's starting to find cases. Obviously, the date's 24, 31, 31. It found those definitely. But check that one out that succeeds. Oops. It's actually wrong. Why is it wrong? Truncation with what? The year. Remember what I said, what's the requirement? It has to be year, 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 year. Now, in all honesty, this program's ever going to print out dates that go before the year 1000. Okay, so it's a little contrived that it actually found this, but the rule is it's got to be formatted that way. And even though PEX says that's an acceptable, or the result came back, nothing failed, it didn't know that this is actually violating a business rule. So even when something succeeds in PEX, you do have to look at the results and say, is this really matching what we want it to do? Because in this case, it is not correct. It did find the error that I thought it would, but even when the success message that it came back with one of the tests is actually wrong. Okay. Now, again, nobody in this room is going to write code like that, right? We're all going to do something like this. And if it's not still running, huh, that's interesting. I've never had a. What's that? No, it's like I said, it's a 0x1. Huh. That's interesting.
So bad the facts on the phone.
Yeah. Well, no, then it's uninstalled because it's still there, but it's actually not even showing up. I wonder if it doesn't allow us to finish. Just finish. Ah, yeah. Thank you. Yeah, down there. So I keep forgetting that the interactivity with PEX is not always the best, and you have to watch down here to see when it actually is done with whatever it's doing.
So you're still analyzing all those previous steps?
Yeah, it's still doing whatever analysis it needs. Well, the one with the dates.
Yeah.
Okay. So now it's there. So if I run PEX on the method that I would recommend it be done, it has one test, one condition, comes back, it's okay. Because there's really no code pass it has to dive into to figure this one out. All right, now the last example I want to go through is the Zune. Who actually has a Zune in here? One of the older ones. You do, Larry. Yeah. Whether you had one or not, you probably heard at the end of last year, people trying to get to their Zooms on the last day of the year and it basically being bricked. It was just sitting there, wasn't doing anything. Shutting it down, doing whatever you possibly could do to reboot the thing, nothing worked. It was just spinning. And when I woke up that morning, Twitter and everybody was just going, what's going on with my Zoom? And everybody was experiencing this problem. And Microsoft came out that day and basically said, the resolution is wait a day. Which is kind of, it is funny that they said that, but there's a reason why they said it. It's because to fix the bug and actually get a patch out to people wouldn't have been fast enough, and the problem was going to resolve itself the next day. So what they said is just wait a day, the next day it's going to work, and then we'll get out a patch to fix it so it doesn't happen again.
It would only happen in 4 years from now.
It would happen on a certain leap year.
Oh, okay.
So you'll see in a moment. So this is the code that is analogous to the driver code that was in error. Now, PEX doesn't do anything with unmanaged code. It's all about managed code. So the driver code is actually written in C. So this is not 100% what the actual code does, but it's a pretty faithful implementation. I tried to keep all the names, all the types, everything as much as I possibly could to match the driver code. And as you'll see it actually ends up finding the bug. So the method that actually was in problem was this one called convert days. Okay. So what I'm just going to do is have PEX run on this, and then you're going to see what ends up in this case. Again, it's all about analyzing what PEX is giving you in its results. And you have to interpret how it does things and what it's giving you as information. All right, so I'm still listening. That's fine. I can keep listening. So I'm going to just dive into what it gives us here. And it's done. Good. So the 0 entry gives an argument on range exception because the actual type in the C# code or in the C code was like a system date structure. And actually passing the 0 in that case would cause a problem. But the datetime type, which is what this method actually returns, the ending results don't work well. Okay, so that's no big deal. If I pass in a 1, that gives me a result. If I pass in a 32, that gives me a result. Which is kind of funny that I found that condition, the February 1st of 1980. If I pass in a 366, I get a path bounds exceeded. And if you're doing code that's datetime based, something that comes back as 366, you're probably making go, it sounds like a leap year bug. Okay? If I dive down out of here, you notice that it comes up with some result here that's this huge value. Okay? And again, this comes up with path bounds exceeded in both cases. What path bounds exceeded is basically saying I couldn't finish because I'm just stuck. I couldn't actually, I'm analyzing okay, but for whatever reason, it just keeps going around the same paths. That's what it's actually telling me. So it's a little different than the other ones where it says I just couldn't get through all my branches. This one is recognizing that it's kind of doing the same thing over and over again, but it never got out of that. Okay? So you can go through some of these boundary conditions, and some of the errors that come back are actually branch and conditional values. And you can go through the same thing of doubling and doubling and doubling and doubling, but you're never actually going to get these tests. Well, the 366 one to come back. Here's why. So I've actually saved off one of the tests here. You'll notice that I have the one test with the huge value stored here. This one will actually come back. If I run this test just right out of the testing framework and run it, it takes a little bit of time for it to eventually come back, but it does. And all it's doing is it's just failing. This number is so big that in the while loop in the code that you're going to see, it takes just too much time and PEX can't get through it all. But it does come back. 366 won't. And here's why. So let me run this under the debugger. Okay. All right, so I'm going to step into the method. Get some of this over here so you can see it better. And I'm going to start going through get day of week. That's some value like 3. I guess that means Tuesday or Wednesday. I don't know what the offset is there. It doesn't matter. Start going into a while loop. So when the data is greater than 365, which it is, it will determine is it a leap year? Yes, it is. Okay. Now, are the days greater than 366? No, because that's the value. So I never decrement. I go back to the while loop. Is it a leap year? Doesn't match. This is what your Zoom was doing, or what everybody's Zoom was doing at the end of last year. It was stuck in this while loop. They couldn't get out. So the fix is to actually change the if condition here, and that's what they would have done. But to actually get that out to people, to everybody to fix this, it just wouldn't have been. The time it would have taken would not have been, acceptable. So they just said to people, just wait, and that's why. And PEX would actually, it catches this by showing you that it can never get out of the method. All right. So any questions on any of these demos or anything on PEX in general so far? All right. Actually, I wish Tim would come back because I'm going to answer one of those questions right now. All right, so real world usage. So kind of getting to what Tim was asking was, how would you come to your analysis? Do you save your analysis, so on and so forth? Playing with PEX is a lot of fun. Well, I personally find it fun. Maybe I'm a little strange, but I find it fun to see what it does when I point it at a method. But in all honesty, as developers, nobody's going to spend hours just right-clicking on methods saying run PEX, run PEX, run PEX. It just would take way too much time. Okay. So what's an alternative to having PEX run on your assembly, run on your code, find things that you didn't anticipate? I'm working on this tool that I call AutoPEX. And what AutoPEX is a combination of PEX and this library called CCI. And CCI is Common Compiler Infrastructure. This is a library that's come out of Microsoft that allows you to do a lot of low-level compiler-like things. It gives you the ability to write out an assembly, kind of like reflection emit. It also lets you read an assembly, change all of its contents, and then write it back out if you want. It also has a PDB reader and writer as well. Code Contracts uses CCI extensively to do a lot of rewriting when it weaves in the contract stuff. CCI is actually, it's not tied to the framework itself. You can get CCI off of Coplex right now. Some of the stuff that is in CCI has been used in other places. Like if you've ever looked at FXCOP code analysis from Microsoft, you may have noticed if you've ever tried to actually write a custom rule, that there's an assembly called Microsoft.cci. And that was part of this suite. But they never officially published the APIs or any of the source code or anything. Now they have. Okay, so you can take a look at it if you want. And so what I'm doing with this is I'm saying, take two assemblies, like the one that you just, on your build server, you compiled last night. Okay, so that's like version 1. And then during the day, you might do some, like builds throughout the day. But then the next night, take the latest release. And if there are differences, which there should be, because people will be checking stuff in and builds will be firing all the time. So I might have version 1.20 here. Do a diff on them. In other words, find the methods over here that are public that aren't in here, and get that list. And then take the methods that are over here that are in here, and look at the implementations, because even though the methods may be the same, the underlying implementation may be different. Capture those methods. And so once you do that query and get all the information back, throw that into PEX on the command line. Okay, so this will also illustrate how you can use PEX outside of Visual Studio. So let me get back to the VLC here and go into the other project. Hey, you're back. Good point. Let's get into the how do you automate PEX.
Okay.
So this is basically doing the idea of you've got version 1, version 2, diff them, get all the methods that you want to reanalyze and have PEX do it like 1 a.m. in the morning in the build box.
Oh, okay.
So I have two assemblies here. So I have the old assembly, which again, these should actually probably have the same names, but just to make it very explicit as to which two I'm targeting. So the old assembly has a class called target. And I have a couple methods that this is saying, this is a new one. This is exactly the same. This is slightly different, and this is private. Just to handle a couple conditions that I wanted to check. The new one has a method that's not in the old one. Has a method that's the same. The difference here that this is a plus in the new one. In the old one, it's a minus. So I wanted to check for that difference in the IL. Because it's not just how many opcodes I have. In this case, these two methods will have the same number of opcodes. But I got to look at each opcode then and say, well, did that differ? So with the plus, it's going to be an add. With the subtract, it's going to be a sub. Even if I call the same methods, maybe those methods have changed. So I want to, put that in my diff list. Okay? So I have my AutoPEX core assembly, and I'm not going to go through all the CCI stuff. I just want to give you a feel for what I'm actually doing here.
Is this something you're writing?
Yes. So it's part of the zip file that I have for this presentation. I eventually want to put it on CodePlex. Part of the reason is CCI's filtering capabilities are a little primitive right now. It can't tell the difference between a method like foo and a method foo that has an int argument. So overloaded methods, it can't tell the difference. It's going to, if you say run hex on foo, it's going to run it on all the foos it finds, which isn't really good. It can't handle generics at all. Generic methods is just really, but I don't want to say it doesn't handle them at all, but trying to do analysis and figuring out which methods you want to call and tell which ones you want to call is problematic. And they know this. It's the whole thing of they got a whole thing of things they want to do, and it's just prioritizing. So they know they have to work on the filtering capabilities in PEX. Okay? But yeah, this is the tool that I'm writing. So what I do here is I basically say I want to get all the methods I want to analyze. And if you've ever used reflection, the CCI APIs will feel very similar. There's a lot of analogies between them. They're just kind of different names, right? So what I'm doing is I'm basically saying get the old assembly. I'm actually getting the old module because every assembly has one main module, and that's what I want to base my stuff on. So I get the old one, I get the new one, and I'm going to start putting a list together. So I run a query that basically says, from the old one, give me all the methods that PEX can hit. In other words, the public methods. Okay? Stuff that here. Then I'm going to do a query on the new one to do the same thing. And then my for each loop, I basically look at all the new methods. And here I'm saying, does it exist in the old assembly? If it doesn't exist, which means that this would come back as null, or the methods names are the same, so now I have to actually look to see, do they differ in their implementation? And that's what is different does. In either case, if those come back with the conditions I'm looking for, I'm going to add to my list, and those are the ones I want to send over to the PEX to analyze. Now the is different, the easy case is to say I added a method that wasn't there before. I know I got to analyze that one. But if the method's there that was there before, now I have to go through this is different. And again, I'm not going to dive into everything in here because that's getting a little bit into the implementations of CCI. But you can kind of follow this as it's not too gnarly. What I do is I look at the body, otherwise the method IL opcodes for both the old one and the new one. And the easy check is to say if the number of operations changed from like 4 to 5, it obviously changed, so it's different. So yeah, they're different. Off we go. Without the case where I just change a subtract to an add, the operation count is going to be the same. So now I need to look at each operation and say, well, if the operation actually changed itself, that's easy, ship it off. It's different.
Have you ever run PEX on this code?
No, I
Oh, really?
No, I haven't. I actually
Well, you
haven't.
could find things you may have not caught.
Exactly, yeah. PEX is a black hole of fun. It really is. I mean, it sounds weird. I know I'm a little strange with what I like to do coding, but you can you start going like, hey, run PEX on this, run PEX on this. I never thought of that. That's definitely something I could do. Run PEX on my AutoPEX. That's great. The other condition I have to look at is the operation method call? Like, is it a call vert, things like that? If it is, then I need to get actually the method that opcode is representing, and then basically look at them and say, are these two different? And if they are, then report back as true. So I'm using CCI just basically do this read-only analysis, get my list of assemblies, and then after I do my assembly differentiation in the command line, I use that to get my list here, and I just print them out. When I get that list, I then use pex.exe. This is the command line tool. Okay? And I'm just starting it up right in my command line tool. And I pass in a couple of command line arguments, basically say, here's all the members, that's what MMF stands for. Here's all the members I want you to hit and analyze. So I basically just pass in the list of all the methods I found from that analysis you just saw. And then I just say, go ahead, Pex, start up. I'm going to wait for it, and I'm going to run to end. Now, there is a little bit of a hitch. You're going to see when I run this, that if I actually did this on a build box, it's not quite the best thing to do. We'll see what it does in a moment. But when I run it, it finds in the new assembly that this wasn't in the old one, and it found the one that's slightly different. But the private one and the one that was the same, it ignored. So again, this is nice because as you're moving from version to version with your assemblies and your build boxes, you can just run this at night with PEX and you check it in the morning and see what it found on your things that are different. Okay? This is a thing that's kind of sucks. Because if you're in a build box, now this is going to pop up in Internet Explorer window, whatever browser you had in the build box.
Coming out with seven was better, but yeah, that's a problem.
So this basically gives you the information about the analysis. And so you can see the two methods are listed there. There may be a switch in pex.exe that I just don't know about that say don't do this, don't show it. Just put all this stuff, and it actually puts this stuff. I go into Explorer, and I dive into the spot that has my stuff here, AutoPex, and bug reports. That's where, you can see I've run it a couple times. That's where it's stuffing all that information that we're running. There may be a way just to say don't show IE or don't show the Explorer when you're done. Then that would be perfect. And here I'm just showing you all the information that comes back from the executable actually running on the output. So this is what I actually recommend doing something like this rather than running PEX. You can do it either way. But I think from like a continuous integration build standpoint, this is probably the way you want to do it.
So did it just tell you the differences between the two assemblies and then generate then run PEX across the differences?
Yeah, PEX doesn't look for the diffs. I had to write that using CCI.
Okay.
But once I get that list, then I pass that list of methods into to pex.exe, and then it does whatever it needs to do in those methods. So yeah, the differentiation to get that diff list, I had to use CCI. Good. So any questions on this?
When you have picked like a small example, like the new and the old one, what do you think would be the performance for millions of lines of code if you have to run this on your project?
So how, if I understand you right, you're asking how long would this take if I just ran this on my box?
Yeah, I mean, compared to a much bigger project.
Yeah, for a bigger project, it would probably take a fair amount of time. And that's why I'd recommend running this on a build server, because if you have a fairly large assembly that you're doing a diff on, it could take 10, 30 minutes, an hour, maybe even 2, because it is very computationally expensive. So if you ran something like this on your box and you had 2 different versions of your assembly, you probably want to run it and go to lunch. Because it might, PEX is not about doing a lot of fast analysis. You do have to let it give it some time to find the things that it needs to find. All right, I have till 11:40.
So what takes time is your utility generation of this, or
Yes.
Okay.
The AutoPex stuff looks at the 2 assemblies, uses CCI's APIs to find the differences between those 2 assemblies, and it takes that resultant method list and just passes those string values into pex.exe.
That first part takes way more time than that.
No, the first part's actually quick.
Okay, so the point
The
is
PEX stuff that's the stuff that's always going to be slow.
right. So to her point is it's not about the size of the project; it's about the size of the change.
Yes, that is part of it. If you don't have a lot of differences, then you're not going to see in your list, you only see a couple methods. But even if you notice with this, with a small project with 2 methods coming up, it still took, 10, 15 seconds. So, again, I recommend if you're using PEX to make sure you're allotting time for it to do its analysis, because it will take more time relative to other things. Yeah.
Thought about like maybe using anything to do your diff first and then just try and pipe that output into
To do end to pen?
and let
Yeah.
the analysis because it has like it analyzes or analyzes what was changed between versions.
I could use NFN, I could use.
This costs money.
Yeah, I mean, there's a lot of ways to get that diff list, you know. I just wanted to use something that is a library that I'm really also enthusiastic about, which is CCI. But you can use other tools to give you that list as well. Yeah.
To go back to that output window that it has like two methods. You did have some
In
more.
Internet Explorer?
Yeah.
Okay, I have to rerun it, but I'll do that again.
Can you just go to that folder?
Yeah, you can, but running it's actually easier. It's surprisingly, it's easier just to do this.
So wait for that, is this just something that the auto text just says it so that you don't have to run text across the whole solution every time? That if you're only doing text like
Exactly.
that, it just says incrementals.
Right. You can actually run PEX here, and I will get back to your question in a moment. You can actually run PEX on the command line and not pass in this switch. If you just do ERM wizard, basically what you're saying is, because this ARGS1, that's the new assembly. That's the one I'm trying to target. And then this one will just rip through everything on it. I'm filtering it if I put this MMF on it. So you could actually have PEX run all the time in every assembly. But if you just want to keep the diffs and keep it a little bit shorter time of analysis, then do it this way. So, okay, here, all right, so what's your question?
This output, I see a lot saying like critical errors running.
Right.
I mean, how does that come up? Like,
Well, in this case, the methods are so simplistic because they're just like adds and subtracts. It doesn't find a lot to analyze. Now, for a larger project, it would probably show you more things that here that would fit. But the analysis is so short in these methods because there's just not a lot to figure out. Probably with the more real-world example, you'd see more stuff showing up here that would be of interest.
Can you show them on the Zoom blow real quick? So we can look at-
I can, but I'm starting to run short on time. So, sorry. But then I'd actually have to dip it too. So, because I do want to also show this stuff called stubs and mocks from PEX, because I think that's extremely interesting stuff. So, any more questions on this stuff? All right. So, here, go back to here, and do the demo there. Now, PEX actually uses a lot of underlying technologies. One that I just talked about, or I just hinted at, is a thing called stubs and moles, which is a mocking framework. It also uses something called extended reflection. Extended reflection is actually a managed profile. If you've ever tried to do profiling in .NET, there's this profiler API that they always tell you, get to know manage C++, because it's and they've always said, you really can't do this in .NET. Well, they figured out how to put a layer around that stuff to do extended reflection. So that's an extremely powerful API. I'm not going to get into that here. There's also this thing called Z3, which is a theorem prover. I'm going to do a demo of it, but I'm going to make it really short because I want to get to the stub stuff. I want to end with that. I wanted you to see just how powerful this mocking framework is. I did steal a slide from PEX's site, which they say you're more than welcome to do. And I just want to illustrate kind of how some of these things work a little bit with Z3 specifically. Because Z3 does this thing called constraint solving. This is some fairly advanced stuff that basically, when you'll see the example, allows you to pass in a Boolean expression and tell you what does that Boolean expression satisfy. This would have been great for me in college when I was in electrical engineering. I was taking a programming logic course. Because I could have just told it, here's my Boolean expression, and you tell me what satisfies this. And my homework would have been easier. So PEX actually uses Z3. It does use extended reflection as well to analyze your assembly while it's running, to do that instrumentation. And it also uses stubs and moles to do some mocking stuff as well. Okay? So I'm going to quickly show some stuff with Z3, and then I'll show you the language of the mocking stuff. All right. So, a little bit here, and going to the Z3 stuff. Basically, I ripped this off from a guy named Bart DeSmet. He has a blog called B Sharp, which if you want to find something that's extremely low-level blogging on .NET, his is like the one to check out these days. He has like something called, I think, Sunday Mind Melting Investigation. What's that?
Really good.
Yeah, he's extremely smart, and he goes in areas that you're like, really? You go there? Wow. You know, he does some amazing stuff. And what he did is he basically ended up, and you'll like this, is he did a link to Z3 implementation. Okay, I don't actually show that here, and I'm not going to get into all this stuff, but basically what he is, you take a look at this example, is he uses Z3 to basically say, if I give you this expression, what can you tell me about it? What can satisfy this Boolean expression? If I give you the A and not A, which of course is illogical, what can you tell me about that?
False.
What's that?
False.
False. Yeah, you'll see. So there's this API called Microsoft Z3, which is put into the directory that installs all the PEX stuff. And then you can use it to do things like you have to set up a config, you got to set up a context, make your Boolean values, so on and so forth. Again, I'm just running a little short, so I want to get kind of blast through this a little bit. You can take a look at this code later on. It's on my website. But at the end of the day, what you'll see when I pass in all these expressions is this. Actually, is this my? Yeah, it is. Case constructor. So what it's going to tell you is things like A and B. The only thing that satisfies that both of these have to be true. If I have A or B, if I have A being true, B doesn't matter. It can be whatever it wants to be. If I go down to the A and not A, no solution. Okay. You can argue with them if you want. But it's interesting that they have this in there because they need this stuff to try to prove out some theorems that they're actually creating at runtime when it does this PEX analysis. Okay? So this is more of a fun thing just to look at, that this is part of the technology base that PEX has. I don't expect anyone in this room to start using Z3 on their projects. That would be a little ridiculous. But it's just something fun to play with. What I think is actually more applicable to real-world development is this Stubbs framework. So you may have heard of things like RhinoMox, MockQ, TypeMock. These are all frameworks that allow you to do mocking in your testing. RhinoMox and MockQ, they take the approach of, if you give me an interface or an abstract class, you can stub that out, you can provide stub implementations of methods so that when I run my test, I'm actually not going to the database or Active Directory or a web service or so on and so forth. I'll actually provide stubs of that while I'm running my tests. TypeMock takes that a step further, and then it allows you to mock things out like HTTP context, operation context, and WCF, things that those other two frameworks can't do, like sealed classes, static members, and so on, because you can't override them. RhinoMox and MockQ are looking for things that it can provide an implementation for, create a dynamic proxy, look for things that are virtual so we can override them and allow you to intercept that. TypeMock actually has its own extended reflection API that it has internally to go hook the profiler API and allow you to set up stubs of operation context current, things like that. Now, I'm not dissing TypeMock at all because I've actually used it on projects and I find it to be a very cool framework. The other two ones are free. TypeMock is a purchased product, and the last time I checked, it was like $700 for a license. Okay. PEX gives you all this for free. And its implementation is actually the slickest one I've ever seen of any of the mocking frameworks. It's so clean, it's amazing. So, here's a kind of a typical example of what I'm trying to get at. Let's say I have a class called data context that implements this interface. Okay? I go into that definition. It's a very simple interface that just has one method, just to keep the example simple. Okay? So it is sealed. It doesn't have a constructor that I can hit. It does implement an interface by returning data, but the only way to get it is it does like a singleton type of approach. Don't do singletons this way because it's not thread safe, blah, blah, blah. But this gives you the idea that if I call current, I'm always going to get the same result back. Okay? Again, this is like HTTP context current, operation context current. So if I want to mock out data context to have this not return data but block, I can't do that with RhinoMox and MockQ. I can only do it with TypeMock. But I can do it with stubs. Now the way to do this with stubs is in my assembly here is you would say my test assembly, which I already am referencing the context one, is that you add new item. When PEX is installed, it gives you this option on the list, which is a stubs, the stubx file. So So you type in the name of the assembly that you want to stub. This is different in the stubs framework than with other ones, because the other mocking frameworks do all the mocking at runtime. Stubs does it at compile time. This stubx file basically says, what are all the things I need to generate for a target assembly? And it actually generates code that you can compile in your assembly instead of having that all done at runtime. So this designer file has a bunch of junk that's generated to allow you to do the mocking. Okay. But what ends up being is a very clean implementation. One thing to keep in mind, if you're going to target like system.service model, it generates everything in that assembly. Okay? So it's a little, takes a little bit of time, and again, this is where they're filtering is something you got to work on. I've asked them, what happens if I just want to filter, if I just want to do mocking on this type of stuff? And they basically said there's no real good way to do that in here yet. There are some elements you can put in the XML file here, but they basically said they don't work very well. So they need to improve that. They need to have a better story around that. In my case, this assembly only has a class and an interface, so it's not that big of a deal. Well, let's look at the test to see how this really works.